In this video, we're going to read some data in from a CSV file, and then we are going to, and it includes XY scatter data. So it's going to have the X's are going to be the speed while performing some exercise. I think the data I took from somewhere was like on an elliptical machine. And then the corresponding heart rate of the exerciser at, at that speed, exercising at that speed. So then we're going to read in that data and make two lists of the sort of the X data and the Y data. And then we're going to use the numpy module, and that has a method to perform a linear regression or to fit it to a straight line or to create a linear model, whatever language you want to use for that. And then we are going to use a matplotlib to plot to make a scatter plot of the data and include also a plot of the fit line and also sort of paste onto the graph that fit line so that it is displayed so that any user can sort of see the data and the fit and work with the fit instead of instead of the data. So you always want to sort of display the equation, which some of the examples I've seen don't display the equation. So I was slightly disturbed by that. Okay. So if you want this code, it can be found at the URL seen here. What I've got is the Python and the heart data next to each other. So let me show you the heart data. It's just simple XY scattered. I do have the first row is labels, and then just a speed and a heart rate. Okay. So I've shown you now what the file system looks like. So I'm going to close my Explorer. Okay. So I'm bringing in the matplotlib, and if you have not done it or not done it in your or a particular folder or virtual environment you've set up, what have you, then you might need to run a pip install at the terminal level, and the same thing for the numpy. So bring in those, import those libraries, modules, but you may need to install them depending on your system setup and history and what have you. I'm also going to use the CSV because I'm going to read a CSV file, and that'll make that a little bit easier. And I'm going to use the OS. I want to make sure that that's what I use first. I want to make sure I find file will be this Python file. I'm finding its real path. I'm finding its the sort of separating off the directory from the file name, and then changing the directory to that directory. So now my terminal thinks it's in the same location as the Python file, and the Python file and the CSV file were siblings in the data file system. So I can just refer to the file now with its name, and they're understood to be siblings. So it'll know what that means. I have my two lists for the X's and the Y's, for the speeds and the heartbeats. I am opening that data I showed you, heart.csv. I'm opening it to read. I'm using the CSV reader here. The delimiter is a comma. I'm doing next, which has me skip one row because I don't want the labels to be mixed in with the data and confuse any regression. And then I start a for loop over the rows, the subsequent rows. One row is taken out with the next, and then I'll loop over the subsequent rows and take row 0 and row 1. So this is something that the CSV does for me, sets up this notion of the row and the sort of the components of the row. And I am sort of working with effectively a split, so it sort of thinks everything's a string, and so I'm casting these things as floats. So row 0 will be the first thing in the row, and that was the speed. And the second thing, row 1, was the heart rate at that. So I called that heartbeats. I had printed them out to see that they came in correctly, but then I commented that out. I'm working with, let me run it and then show you. I had a lot of things to make it pretty, not that pretty, but so I have this light blue background and this blue fit line, and the line or the scatter points are a dark green with a dark red around them. I have a title, I have axis labels, I have a grid. Okay, so you've seen what we're getting out of it. So here is the code to just to grab what they call the axes, and then I can use that axes to sort of set that blue. So this is CC, CCFF. So that is, it's got the most blue. It's a light color because all these numbers are high, but it's got the most blue. So that was that light blue. Okay, and here I'm adding the grid with an alpha of 0.5, so it's a grid with some transparency. So that is this sort of faint gray grid that you see there. Here we are on the plot using the scatter method. So this is going to show me my x. I give it x and y arguments. My speeds and my heartbeats are my x's and my y's. Scatter is not going to connect the dots, just keep them as dots. The s was the size. And so if you want bigger, make S bigger. If you want smaller, make it smaller. Obviously, alpha is some kind of opaqueness transparency control, so you can have them block out everything behind them or not. And then there is the color. This is it's RGB, so this is a dark green, low numbers, but more green than anything else. So that's a dark green, and edge color was that around the dots, that dark red, and that's more red than anything else. Okay, so that was making the scatter plot. Now I jump off and use NP, which was the numpy that we brought in. And numpy, I'm using the polyfit method. Again, the x's and the y's, the speeds and the heartbeats, and then we're doing a polynomial fit of degree 1. So this is basically fitting it to a straight line, and what we're getting out of that is a fit slope and a fit intercept. So here they are, slope and intercept. Okay, and then I want to plot that fit. And so I need to generate some x's. And so I'm using a numpy method, linspace, and I'm creating from my minimum speed to my maximum speed. I'm making 100 points. So I'm just sort of making a bunch of points, quasi-continuous, if you will, that go and then span my range of x's. And now I'm going to, on my plot, I'm going to plot them. So plot will connect, whereas scatter does not connect. So I probably didn't need this many points since it's a straight line, but there you go. But if it were, say, if it were indeed a polynomial, then it would make sense to have all these points. Okay. Here, so I'm plotting, here are my x's, and then my y's are the fit equation with those x's plugged in. So I'm working with sort of a list and applying this function to all the items in my list. And so I'm taking my slope and multiplying it by my x and adding my intercept. So that applied my fit equation to all of the x's that I sort of generated. Made this color a bright blue, and this LW controls the width of the line, so I can make the fit line thicker or thinner. So that was the blue line. Okay, I wanted to display my equation. And so I'm doing y equals some number times x plus some number. So I just have a string here, and then I'm putting in the slope in the first position and the intercept in the second position. And I am showing 2 decimal places after the dot. So that's my formatting of what's being substituted in here. That's this dot 2f. That's giving me 2 decimal places. Okay, and then I need to place that equation. Here I just made this string in memory, but now I want to place it on the graph. So that is plt.text, the text method for the plot. And then I need to provide an x and a y. So I said that I wanted this at 4, 1, 10. And that is the beginning. The x here is the beginning of it. A number of things, it's the middle, but in this particular case, it happens to be the beginning. And so there I'm positioning it at 4 and 110. And then my text is the fit equation that I created up here, and I'm doing a font size. So again, can control a size. I'm giving my plot a title. I'm labeling the x-axis. I'm labeling the y-axis. I am saving my, using savefig to save it as a PNG. So where am I at? Sorry, I should have scrolled beforehand. There's my linear regression, and here's the PNG file I created. And then I'm showing it so that this is the show, sort of what brings it up in a pop-up. All right, so that's what I wanted to show you, an XY scatter graph with a fit. And so it was matplotlib, or the CSV module to read the data, the matplotlib to plot the data, the numpy to create the regression, and sort of using these all in conjunction to read the data, to fit the data, to plot the data, and show the fit and display the fit equation. Right, that's what I wanted to show you in this example. Thanks for your attention.